Oh, hello everyone. It's April 20th. Okay, this is not expected. Not expected at all. So it's supposed to fly back today, but the flight got delayed and I have a layover. My previous flight didn't catch it. I got a delay. The connecting flight was not caught, so I have to um, stay until tomorrow. But thankfully, the airline did um, offer me a hotel night and a taxi to the hotel, and also vouchers for meals. So, still bad, still unhappy, but yeah, it was an accident. Anyway, there's a good part of this. The good part is I'm able to do this today. Otherwise, actually, it's going to be a little bit difficult to handle. But we have another hard one. So for this one, I have a new method. I wrote it down, so I'm gonna try it maybe later today. But first of all, let's take a look at this. This doesn't seem to be easy. If you look at the password 43, maybe it's not that hard. We'll see. There's a group of n members and a list of various crimes they could commit. While profitable scheme, the ith crime generates profit I. Where's the profit? Okay. And requires group I members to participate in it. If a member participates in one crime, that member can't participate in another crime. Let's call a profitable scheme any subset of these crimes that generates at least minimum profit, and the total number of members participating in that subset of crime is the most n. Return the number of schemes that can be chosen that you can get minimum profit. Since the answer can be very large, return the modulo. Okay, so the first crime has profit 2, the second crime has profit 3, and the first crime needs 2 people, the second one needs 2 people as well. And if you have participated in it, that member cannot participate in another crime. Okay? To make a profit of at least 3, the group could either commit crime 0 and 1 or just crime 1. In total, there are 2 schemes. That's an easy one. Either do crime 1, so we got 3, or crime 1 and 2, or 0 and 1, then we got 5. Okay? So basically what we're saying is we want to know which of the groups. This is a knapsack, right? Because you have group, you want to fit these groups. This is like weight of the parcels, right? A knapsack, you fit items into the bag, and the bag has a limit, has a maximum limit. Now the maximum limit is n equal to 10, and the group, right? Group basically is the weight of each item, and the profit is the profit. So the question is asking you how many ways you can fit this bag such that the profit is at least the minimum profit. And based on the n size, so again, confirm that this is a knapsack problem. So do you remember how to do knapsack? I think this is like the 10th time I've asked myself the same question. And we all know knapsack is important, right? And every time I read the solution, I always know how to do knapsack, but I kind of forget how to do it. I mean, if I remember right, for each item, right? For each item, or you can say for each group, you can decide, so you can either use it or not use it, right? If you use it, then we will have the profit, and it will plus whatever the remaining you need to do. If we do not use it, then it's just the remaining. I think that is knapsack. So knapsack, the complexity is 2 to the n. Now we have a minimum profit, which means we can we don't have to go through all, right? Because once you have reached a certain level, like let's say you have already gone above the mean profit, then the remaining can be as much as you want. Therefore, in the recursion, we probably need to pass something more, right? So we need the index in the recursion, and we need the current profit, right? Current profit. So the thing is, if the current profit is larger than the minimum profit already, okay? If the current profit is larger, then we can take any of the remaining, right? Any of the remaining. Then we can take any of the remaining. And if the current profit, if we go to the end, and the current profit is not good, right? Then we shall return 0. Okay, let's give this a shot. Okay, so right, so we're gonna have def helper. We need an index and current profit, and we'll return an integer. Oh, right. So we should say if n equals len group. Okay. Oh, hold on. If index is equal to n, right, and current profit. If index is equal to n, we have exhausted all the options. Then we shall return current profit is larger or equal to mean profit, right? Which means if we exhaust everything and we have enough profit, and then that's one option, right? That's one. If it's still bad, that's nothing. And if current profit is already larger than mean profit, so n index has not reached the end, then that means with a current, so from the index to the end, we can pick whatever, right? We can pick whatever. Basically, we can return 2 to the power of something, right? Do we have the -1? Yes, we have the -1 because we cannot do empty set. And it should be n minus index. Is that correct? Let's say we have 3 and I am at position 2. And 3 minus 2 is 1, but I actually have 2 more left. So I think we want to know how many, right? So index is 1. 3. Yeah, that's actually correct. So I can say this mod. Okay? If current profit is larger, otherwise if the current profit is smaller, then we can do helper index plus 1, current profit. So this is saying we're not taking the current one, right? We're not taking the current one. Or we can say, so we have that many options, right? Wait, hold a second. The current profit, and then we want to know, given the current profit, right, how many we have. And then we can plus, we take the current one, all right? So helper, still index plus 1, but current profit, plus, and also has to be at most 10. Oh, there's one more consideration. So if that's correct, right? And we have to current profit, current group, okay? And if current group, actually this one should be first. If current group is larger than n, right, at most, and if this is larger, then we should return 0, right? If it's smaller, and if this, okay, so now we have to say this is still current group. We did not increase anything, but here it's going to be current group plus group index, so we use this, and current profit plus profit index. And we should return this plus this, right? Mod. Should return helper. Hold on, something is not right. Of course it's not right. So return helper, we start with 0. Current group has nobody. Current profit will have nothing. Do you think we shall, I don't know, memorize it? I mean, I don't think memorization will hurt. What do you think? First, make sure this is correct. And main profit, group profit, and main profit, group profit. Oh, I got wrong. Profitable schemes. Seven. The first one's right. The second one is wrong. Okay, so what goes wrong? The second one. I should use all of them, right? Three, 5, 8. Index is 3. 5 is the current group, and 8. So I think we just take, yeah, I'm taking this, at least 5. So that's correct. Yeah, well, we can take any of these. Yeah, it's any of these. And then 2, 3, 7. How come I only get 5? If the current profit is larger than the minimum profit, I think I basically stopped right here, right? Yeah, so I try not taking it, then I try taking it. So that will be 1, right? And I go previously, I say I'll take this. So that shall give me 2 to the, because it's 3 minus index. Index is 2. And the current profit is 7. Yeah. Index is 2. And the current profit. Hold on. So we're dealing with the current index, right? And then, yeah, we're saying the current profit is already. So we add 2. Current 0, 1, 2. Now it's 0, 1, 3. We add 3. Because we're at 2, so we take 2. So now it's 3, so that's giving me 1. And now the current is 2, right? I'm getting 2. And then now I already get more. So this shall give me 1, right? And hold on. Yeah, I'm looking at yeah, I take this, right? I take this. Now I'm at this. So that should give me 1 already. Right? So I would take 7. So that's 3. And now we say take 6. Right? 1. So that shall give me 2 to the 2, 4, and 3. 3 plus 3. Wait. I did have 7. Oh yeah, for sure. This is a half 7. But the thing is, we have, this is 1. This. Yeah, current profit is larger than, so that's 1. 1, 2, 3, 4, 5. Oh, that's why we have 5. That's bad. Hold on, where did we got wrong? Current group, too much, yes. Index got out. Yeah, that feel like right as well, right? And then I say current profit is already larger than, which means when I get into the current index, the profit is already good. So I say I can do whatever I want for the remaining. And the remaining should be n minus index, right? N minus this index. It give me the number of remaining that I can do any combination of them, right? I can do any combination of them, which is 2 to the n minus 1, right? Which means if you give me 6, 7, 8, right? I say at the 6th position, I say I either do so this is 0, 1, 2, right? So I do 1, 0, 0. Or I do 2, right? 2, 3, 2 to 6, right? No, wait, 1 to 6, 1 to 6. Okay. And 1, 0, 0. We will do 2, 0, 0. Or 2, 3, 7. Yes. And then I will do 3, 0, 0. Or 3, take that. What's that? 5, 8. Right? And then 3, 5, 8 means we take this, so that's 1. Right? That's 1. That's correct. Just take 8 by itself. And then 3, 0, 0 is bad. So 2, 0, 0 shall return 3, 0, 0, which is a 1. So this should be a 1. And 2, 3, 7. 2, 3, 7. So we take number 2. So we are at 2. And then we have already 7. So this one shall return 1. Right? Because that's 2, 3 minus 2 is 1. 1 minus 1 is 0. Hold on. Hold on. Position is 2. Right? And then we have 3, so we have 1. 3 minus 2 is 1. 2, so that's 1. Yeah, that's 1. So that is 1. Right? So return 1, 0, 0 shall return 2. And then 1, 2, 6. 1, 2, 6 shall return 3. Therefore, the initial is 5. That is correct. But you're overlooking, right? You're overlooking some options. And those options are that, yeah, I know which 2 I overlooked. So where do I supplement? So that is just taking this, right? And then we have to get taking this, which means I probably need to have a self.res. Right? So okay, what we want is when we take the current, right? So we take the current How do we handle this? Is this take the current? This is take the current, or not take the current. Oh, hold on. This is everything, right? We can take everything. Oh, that's not right. That's not right. You might not be able to take everything. Because there's a limit. There's a current group. There's a limit. So you need to know what is the current group. Oh. Let me think again. If we hit a certain point, right, and the profit is larger than the minimum profit, then yes, I can take whatever. But then I have a limit on the group, right? So I need to... Oh, how do you do that? You need to check, right? You need to check. How many you can do? Because you cannot get higher than that. Hold on, group.length. Yeah, the group, these values added together might be larger than n. Yeah, it's understandable. That's what knapsack is. Still, that doesn't make sense. It's not including this, right? When it's not including this, why I don't get all the value back? Hmm. Seven by itself, I did not consider that. No, you did. You did consider. So when you do, right, 237, 0, 1, 2. Now I decide to not take one, or we take one. And if you take one and you have the remaining, if that one you take is already bigger, then it shall count by itself. I currently do not have an option to count by itself, because you always say this has to be combined with something, right? This is not taking it, this is taking it when we have to combine with something. And then when you combine with something, it also requires you to say this, I must have whatever this, right? If this is 0, then this will so what should we do? Well, what we can do is here we can say this is not taking it, right? And this is taking it by itself. So this is not taking it, not taking index. And this is int taking it by itself. taking it by itself, it requires. How would you take it by itself? You take it, and then this is the remaining, right? You do that. And when you do that, we can return a 0, right? That's what we have. You return a 0. So we take this, and it would take, and this give you 0. Then it needs to depend. Yeah. Hold on. Hold on. Hold a second. Take by itself, all right? Or we take it and we have to take the remaining. Okay. Hold on. So we can say not taking it. Let's do it this way. Clearly, this is not taking it. Right? This is not taking it. This is not taking it. Of index plus 1, current group. Yeah, this is not taking it. Or we take it. Now we take it has 2 possibilities, right? One is I take it just, by myself. And how do you count that? I take it by myself. And the remaining, right? If I take it by itself, the current group will increase, the current profit will increase, right? Then we can say, if I take by myself, if it's already larger, then there's no good. You cannot take. If it's smaller, right? So I can say, now take index, right? Then current group, well, plus equal to group index. So if current group is larger than n, if current group is smaller or equal to n, smaller than n, if current group is equal to n, and that's it, we cannot take any more, right? Then, I mean, it's fine. I can always, and you want to analyze it here, I mean, it's okay, right? If current group is equal to n, then that's it. Rest plus equal 1. Right, and then rest equal to rest plus 1. So we take this, then we cannot take anymore. If current group is smaller than n, okay, then we should try the next one. How do we try the next one? We say rest equals to rest plus listing, right, helper. Index plus 1. I already done this. Right. Else, if it's larger than, then we don't do anything. Then we'll return rest. So now, this still holds, right? If current is larger than, then we can return 0. So like if it's bad, then we should return 0. If it's equal to n, then we check this. Now this is the trouble. If current profit is larger than, right, then we need to know how many we can use, right? We might not be able to use all of them. That's the thing. We might not. Therefore, maybe we need to sort group and profit, right? Sort them from small to large. And then when this happens, we need to check which ones can combine together. Okay, and how would you do that? Well, current profit. So I know how many more I can get. I have current group, so we can say n minus current group is the remaining values. That's actually not true. Yeah, that is true. N minus is current remaining members we can have. And then we need to say, we'll find the largest. Then we can say do 1. So this is a problem of given the list of values, how many combinations do we have such that the sum is smaller than that? Can we solve this one fast? A combination of everything. How do you do that? We'll go from small to large. I have a small value and getting bigger. And I want to know, I can say, okay, if I take the first, wait, are you telling me when I do 2 levels of helper? 2 levels? What? But that's basically, yeah, we're asking this, how many combinations do we have that will fit? But aren't we just counting all those combinations? You are counting all those combinations. Like, how many are they? That's a knapsack. When a knapsack inside a knapsack. That seems stupid. Let me run this one first. This one's still wrong. This one's still wrong, man. I thought I already fixed it. I thought this one already fixed it. No, this one does not fix it. It just said if current group is n, then we do 1. Right, we add this current group. Yeah, and the current group is smaller, then I still do this. Yeah, you did not fix anything, man. What you did not fix is you add the current one, right, which is good, and then you have to count the current one, right? You have to count the current one. How do I count the current one? Because if the current one is good, then you shall be able to take by itself, right? Take this and yeah, this is also not right. I don't know what are you doing, man? So we take this, right? Current profit plus equal to profit index. If current profit is current group is smaller than n, smaller or equal to n, okay? Then we say if current profit is larger or equal to minimum profit, right? Then result plus equal 1. Take by itself. And then take just by itself. And then we try, taking this and something else, right? Taking this and something else. Like combine taking, because if this returns a 0, then we don't take it. So we have to take it before. Oh, then we have duplicates. Dude. Why knapsack is so unforgiving? What goes wrong here? That's 1, yeah. So we say, if we don't take 1, we take this by itself. That will be 1. And then when you take 1, and then you take this, right? You take 1, and then you take this, and this only gives you 1. That is not right. Right, because 2, 3, 7, position 2, right, we have profit is 7. Then you will do 3, 0, 0. Now 3, 3, 7, which means I don't take 3, 3, 7. Or I take it, right? And that will give you 2. Yeah. Like, hold on. If we don't do this, okay? And we just do jeez, I don't even know how to fix this thing. If we just return right, helper index plus 1, current group, current profit plus helper index plus 1, current group plus group index, current profit plus profit index, mod. I think this one will be right. Yes, but that is pure knapsack. I think it will time out. Yeah, you do this, definitely timeout, because that will be 2 to the 100th, right? 2 to the 100th. So the problem we need to solve is when the profit is larger than the minimum profit is larger, then what do you do? Yes, yes. And then the initial, yeah, this one, we need to figure this one out. Okay. So why does it not work? Must not work because it's not working because when this happens, I'm just put this one here, right? When this happens, you're discounting, right? You're discounting the situation where, yeah, when you're landing on this index, right? You're landing on this index. You have your current profit. Well, this is without hitting this current profit. We will find all the ways. Yeah, okay. We'll find all the ways. You know what? I want to try. I want to see a timeout. Curious. At least the confirmation that I wrote the knapsack correct. Here's what timeout. I think even if you DP it, it will still timeout. It will still timeout. I think it will still timeout. Yep. Did we get more? Kind of just verify that DP actually works 7. Oh yeah. DP does help. Help tremendously. Help tremendously. Alright? Helps tremendously. So yeah, we should take these test cases. These are good test cases. So yeah, like just as I had expected, we have to be smarter, right? And then when I say be smarter, it means we have to find a new way to handle this, right? Like when this happened, right? And of course this is not right. I don't know what it is at the moment, but by doing this, we can just return something, right? We can return something. We can return something. We don't have to keep going. Otherwise, right? Otherwise, then we do these two, which is perfectly normal. So now we have to handle this. Now, how do we handle this? How do we handle this? So the current profit, right, is larger or equal to mean profit. I mean, I could just do, I can do 2n minus index. I think this is right. Yeah. But this is still going to be wrong. I'm pretty sure this is going to be wrong. I just want to double check that this is wrong. This should be wrong because I did not check. Yes, good. Wrong is good. Wrong is good because I need to make sure that my analysis is on point. So now I am very sure that the analysis is on point and I know where to work on. The part that is bothering us. I know which part. Hold on, let me get these two good test cases. that's that. And this is the other test case. This is actually fun. I like this question. Yep. The problem is we go beyond this. So how do we, right? So I do believe we probably need a helper 2. Well, of course, LRU cache. Right. So that's one. So we need another helper. To given, right? Given a list of values, how many different ways can we pick? Right. So there will be a helper 2. So we call it helper 1. Okay, helper 1 and helper 2. So still index, right? And then we want to find out, do we use current group? Yeah, we can use current group. How many different ways can we fit? What if there are a lot of ways that you can fit? No, it won't. Oh, will it be though? No, it won't be, because n is only 100. So there's only so many ways you can do. Yeah, we can do current group. It's fine. So we just want to know how many different ways that we can hit to n, right? We hit to n. Right? And then we say if current group is larger than n, that should return 0. That means this is a bad option, right? Otherwise, we say if index is equal to n, then we shall return int current group smaller or equal to n, right? If we exhausted everything, then the current group shall, if it's smaller than n, that's 1. If it's larger than n, then it's bad, right? It exceeds it. Otherwise, we will say we either take the current or we don't take the current, right? So if we take the current, that will be helper 2. Now if we don't take the current, index plus 1, current group, right? If we don't take the current, if we take the current, that'll be current group plus group index. And we'll do this thing mod as well. Right, that's the total number of ways that we can get. So when we do this, we shall return helper 2 index and current group. Helper 1. Oh, that's a lot of computation. We need a memo. Let's call it default dict. Okay, it's default dict int. If index current group in memo, not in memo, then we can say memo index current group equals 0. Memo index current group equals this. elif else memo equals memo index current group equals this. Turn memo index current group. All right, let's check the easy cases. They probably don't even use it. Oh, looks like we might have hit it. Two knapsacks. All right, try this one now. Might take a while, but we got it. We got it. Okay. Pretty satisfied, pretty happy. How long did we take? How long? 57 minutes. Jeez. 1 hour just from one problem. That's okay. 879, right? It was obvious. It is obvious that the problem requires knapsack. Is that how you spell knapsack? Yeah, requires knapsack. Now knapsack, however, the constraint, right? The constraint is too big. The constraint is a bit too big for knapsack. Well, the constraint is 100, but 2 to the 100 is too big a time complexity. Now the problem, right? The problem. Now the trick is that when we hit an index and profit and a current profit is already mean larger or equal to main profit, we do not have to continue with the original knapsack. Instead, we need to find out, right? We need to find out the total number of ways for the remaining groups that can fit n. Essentially, this is a second and simpler, actually, knapsack problem within the overall knapsack problem. Also, both knapsack can be memoized. Okay, that's the runtime. I think it's still 2 to the n, but let's take a look. Oh, they call it DP. Oh, it is DP. Bottom up DP. It is. Is that considered knapsack, right? Three-level DP. Holy crap. That's very different from what I was thinking. Mine is... What is mine? This is a knapsack, right? Yeah. If profit exceeds the minimum required, it's a profitable scheme. Total ways. Find position count. That's it. A 3-level DP. That's it. Position, count, and profit. That looks very simple, man. This is basically not taking it. This is taking it. Dude. That's it? That's actually very easy. Okay, I shouldn't say very easy, but... Three-level DP from the official solution. Index, current group, current profit. I feel like okay. Uh-huh. Maybe I can do this. Current group. If current group is smaller than n, then return res? Like that? No, that's not right. Hold on. Smaller equal to. Oh, it does work. Holy crap. Huh. That's exactly the same as this. Yeah, it has to be smaller or equal to. But isn't this the same as what I submitted first time? Slightly different. I said if it's smaller. Actually, I'm not sure. Maybe this one also timeout. It does not. Wait, what's the difference between this and this? Right? What's the difference? Well, the only difference is, like, this line is the same. I mean, that's the same. The only difference is I'll call this, right? I'll call this. But if I call this, the next line is already larger than n, and we already returned 0, so it should be fine. Well, apparently it's not fine. Right? Apparently it's not fine, this one. No, it is. But it is slower. Because we made more calls. Wow, I did not expect that. That should not make any difference. This should not make any difference. So the only difference is if current group plus group index is smaller or equal to n, res equals, and then return res. That is the only difference. And of course we don't do this. That's the only difference. And this one will work. And the other one will not work. Yeah, look. Shave off 2000 milliseconds. Okay, so what I think is, how should we put this? By doing this, we reduce some calls, right? So we don't call this DP again and again. It makes sense, because if you call this the next round, you will first call this again and then call this again, and all of those are, if it's useless, that's useless calls. Makes sense now. Make perfect sense now. So I was correct, right? It's just the way that I, handle the no, we changed it, so it doesn't work anymore. No way. Yeah, it is a knapsack. It is a knapsack. Hold on. So I have one more trick up my sleeve. So this one's bad, right? So what if we memo it? I don't know. If we memo this instead of using this memo, right? Again, if index current group current profit not in memo. If index is this, memo key equals this thing. So I have to repeat this. If key is not in memo, this memo key is equal to this. Else memo k is equal to this. This. If this memo k equals memo k plus this mod, return memo k. That should still work. Not sure. Maybe it's still bad, but anyway, 3,269 milliseconds last time. Now I think this one will still be bad. So the way is, yeah, it's still bad. It's still bad. But I don't like to do my memo myself. I like the, this is clean, right? But this is from the official solution and it didn't work. Holy crap. This is from the official solution. I was very close to this, but didn't realize that by checking current group and n before recursion, we can save a lot of unnecessary function calls. Unfortunately, the official solution no longer works for Python. Yeah, this solution TLE. So therefore, the only solution is this, the knapsack problem, the knapsack. Which, honestly, I think I can update. What if I do the same thing, right? What if I do the same thing as here? Okay. I do this. Rest equals to this. Current, if this smaller than this, then we say this, let's say helper 1, right? And then we do helper 1. And then we don't do this. Update. And what's the update? Update is, and here we can do the same thing, right? If you think about it, we can say if this, right, else. Yes, k equals index current group. If k is not, right, then we don't do this. We say memo k equal to this, and current group plus equal to group index. If current group is smaller or equal to n, memo k equal to memo k plus this mod, and then we return I'm okay. Update. Use the trick in solution 2 to reduce the number of unnecessary function calls, recursion calls. All right, let's try this one. This is fun. Might be even faster. Slightly faster. All right, so what are the discussion? 2018. Jesus. And how did your solution work? So telling me it has to be bottom up. Now how come this one works, but my solution doesn't work? This looks very similar to my solution, right? Jeez. Throw the 2 into it. Oh, that's probably not gonna work. What did I do wrong? How is this different from this? Huh? You tell me. How is these two not the same? No way. No way. You're kidding me. You are kidding me. Hold on. This one's bad, right? It's bad. Don't do this to me, man. Don't do this to me. That would be too cruel. Nope. It is faster, but not as fast as this one. What the hell? Dude, what did you do, man? What did you do? Like, what is the difference? Uh-huh. People plus smaller. Ew. Nasty. Minimum. Holy crap. Did you not see that's not in the solution? Oh my god. That's the trick. Okay, I'll upload you. Okay, so... Nah, this is wrong. Official solution. This is not official solution. Official solution. Almost identical to solution 2, but with one extremely important. Minimum. All right, let's understand why we need to do. Notice the second recursion call. The current. That's current group, dude. Sorry. This. Current profit is passed as the minimum of current profit and minimum profit, right? So I think this is to say if, so this is to say, right? This is to say if the current profit is already larger than minimum profit, we don't have to create a new state, right? We don't have to create a new state. This way we can decrease the total amount of state visited. Because we don't care. We don't care. Oh, now it makes sense, huh? Oh. Now it makes sense. Now it makes sense. Okay. So what do we learn? Well, for one thing, the knapsack works, right? The knapsack way of thinking works. The knapsack within a knapsack. But the 3-level, yeah, this is really a important trick. Oh, all right, good. That's it. I will do this tomorrow. I'll see you guys tomorrow. Adios.